We want to factor and solve polynomial equations. A polynomial equation is going to be a lot like solving quadratic equations, except they'll have a bigger degree. The first thing we're going to want to do is look for a common factor. And when I look at x cubed, x squared, and x, all of them have an x in there. So what I'm going to do is factor out an x out of the entire polynomial. And how we do that is dividing the x out. And that brings it outside. So x cubed divided by x is just x squared. 2x squared divided by x is 2x. And 15x divided by x is just the 15. Alright, now what we're left with is a quadratic, which we know how to factor into x and x. And we factor 15 into plus 5 minus 3. And that'll give us a plus 2x in the middle. Now I have three factors that are being multiplied together to equal 0. And we can use that zero product property to solve this thing because it equals 0. So we set each factor equal to 0. Either x equals 0, or x plus 5 equals 0, or x minus 3 equals 0. Solving each of them, x equals 0, or x equals negative 5, or x equals 3. And there are our solutions. We can also look for special factor patterns. And then even though we have an x to the fourth and x squared in there, well, first step I'd notice both of those terms have x's in them, and they both have 9's. So we could take out a 9x squared. Doing that leaves us with x squared minus 16. In the middle, there's the difference of two squares. So we factor again into x plus 4 and x minus 4. Set each factor equal to 0. And solve. This would just mean x equals 0, x equals negative 4, or x equals positive 4. We'll look at a couple other special factor patterns that you probably don't feel as comfortable about. The first is the difference of two squares, which is much like the difference of two, or the difference of two squares is a lot like the difference of two cubes. And we're going to look at the difference of two cubes, x cubed minus any number cubed. If we're going to factor this, how we factor it is like this. First, just x minus a. We take those things that are being cubed and just plug them in there, x and a. Now, the second factor is going to be a longer factor. It's going to have three different terms to it. The first term is going to be x squared. So the first thing squared. The next term is the product of these two, ax. And the last thing is the last thing squared, a squared. And kind of the general rule is that when we're dealing with sum or difference of two cubes, you only get one minus sign, and we've already used it up. So these are both going to be plus. Now, if we want to apply that to factor x cubed minus 27, we're going to factor that into x minus 9, or not 9, 3, because that's the cubed root of 27. Then the long one is going to be x squared plus the product of the two plus the square of the last thing. The sum of two cubes is very similar. If we start with x cubed plus a cubed, we factor it into x plus a first. And then, just like before, square the first thing. And we do the product of both of them. And then we square the last thing. We only get one minus sign. Hasn't been used yet, so use it right away. Alright, so, let's try one. Let's say 8x cubed plus 125. If we're going to factor that, the cube root of 8x cubed is 2x, and the cube root of 125 is 5. Plus in the middle, plus in the middle. Now we figure out the big one by squaring the first thing. The product of the two is in the middle, and then square the last thing. We only get one minus sign. We haven't used it yet, so use it. And there we go. The last one I want to look at is factoring by grouping. This is also a technique that you might feel uncomfortable with at first, but it is really slick for dealing with third degree polynomials. And what we want to do is just factor it by looking at each half. And just looking at the front half of this polynomial, we've got x cubed minus 3x squared. All I'm going to do is take out the common factor, x squared. And I'll be left with x minus 3. Now, look at the second half and take out a common factor there. Between negative 16x and 48, the only common factor is negative 16. And we're left with x minus 3. Right. By cutting this polynomial in half and factoring each half, what we did was take something that initially had 4 terms in it and split it up into something that just has 2 terms in it. Each of these 2 terms has a common factor as well now. That common factor is x minus 3. If I took an x minus 3 out of there, when I take x minus 3 out of the first term, I'm left with x squared. Take x minus 3 out of the second term, I'm left with minus 16, which is the difference of 2 squares. So we can continue to factor. That would be x plus 4, x minus 4. And now we have the entire thing factored. So go ahead and solve it. Set each factor equal to 0. And solve. So x equals 3, or negative 4, or x equals 4. Right. Factoring by grouping doesn't always work, but it's a good thing to try. It might be able to allow us to factor larger polynomials. So let's try one more. X cubed plus 7x squared minus 9x minus 63 equals 0. And we want to factor it by grouping. So, or it's also called factored by parts, because we'll break it into 2 parts. But in the first half, each of those have an x squared in it, and we'll be left with x plus 7. In the second half, we could factor out a negative 9, and we'll also be left with x plus 7. That's how you know it's going to work, when what you're left with is the same, this x plus 7. That's what's going to get factored out in front. We'll be left with x squared minus 9, which can be factored again. That's the difference of 2 squares, so that's x plus 3, x minus 3. Set each factor equal to 0. Oops. And solve. X equals negative 7, x equals negative 3, or x equals positive 3.